Okay, I mentioned coterminal angles earlier, but we're going to talk about it again a little bit now. Here is a set of axes. I'm having trouble drawing that for some reason. And I'm going to draw an angle. Let's see, I don't want to make it too nice. Let's make it, let's do this here. This is my angle here. Now, the thing we want to talk about in this section is finding other angles that have the same landing place, if you will, but have different numbers of degrees. But the way I'm going to explain it is not actually how we're going to use it. We're going to kind of use it in reverse, but to get us started so that you can see what it is we're getting at here. Let's take this angle that you see on the screen and let's add a full cycle starting not in standard position, but starting from where we currently are. We're going to add 360 degrees. We're going to add another full circle around that. So this angle, the white angle, looks like it might be about 75 degrees. I'm just kind of estimating there. And I added an entire cycle to that. So I added to 75 degrees, I added an additional 360 degrees. And if I add those together, I get, there's a 5, 6, and 7 is 13, carry the 1, you get 435 degrees. So we say that 435 degrees is coterminal, that's an L, to 75 degrees. Now, if I take that angle, that white angle that I started with, and add 360 degrees, and then add another 360 degrees, I get another angle that's coterminal to 75. So this time I added 360 degrees twice, that's 720 degrees. If I add those together, I get, there's a 5, there's a 9, there's a 795, is also coterminal to 75 degrees. And it is coterminal to 435 degrees. Or we could say 75 degrees is coterminal to 435 degrees, or to 795 degrees. It doesn't matter which order you do this in. What we're saying is that 75 degrees is equivalent, and for that I'm going to use a 3-part equal sign. That's what that means, is equivalent to 435 degrees, and that is in turn equivalent to 795 degrees. If I take this angle here and subtract 360 degrees, I'll get, let's see, I have to find somewhere to do my arithmetic here. 75 minus 360 would be the same as 360 minus 75, except the sign will be different, right? So I have a 5, 15 minus 7 is 15 minus 7 is 8, and 2, so 2, so negative 200, negative 285 degrees is also coterminal to 75 degrees and is also coterminal to 795 degrees. So my point here is that there are different ways to write the location of the terminal ray of an angle, right? These angles are not all the same size. This green one is much, much bigger than the pink one, and the pink one is bigger than the white one, and the blue one's a negative angle, but they all have the same sort of final, well, they all have the same terminal ray, right? They all land in the same place when we're done. So if I'm working with an angle that is 795 degrees, that's pretty awkward. Even worse still, negative 285 degrees. It's pretty awkward to work with. But if I can find its coterminal angle somewhere between 0 and 360, that's going to be a lot easier to work with. So we're going to do that fairly often. We're going to take angles that are bigger than 360 degrees or smaller than 0 degrees. In other words, they're negative angles. And we're going to kind of convert them into angles that are between 0 and 360, just to make them easier to work with. So what I showed you here was how to take an angle that is between 0 and 360 and add 360, or in the case of this example here, subtract 360 from it in order to find an angle coterminal to it. But in fact, the way we're going to end up using this is to take an angle bigger than 360 and subtract 360 until we get down to an angle that's between 0 and 360. So let me do one example like that. If we're asked to find an angle coterminal to the angle 1272 degrees between 0 and 360 degrees, all we need to do is take 1272 and subtract 360 from it. We get 912. I am just using my calculator for this. This is all calculator work. That's absolutely fine. Okay. That's still bigger than 360. So I'm going to subtract 360 again, and I'm going to get minus 360. I'm going to get 552. That's still bigger than 360. So I just need to subtract 360 again. And I'll get 192. And this is between 0 and 360, so that's my answer. 192 degrees is coterminal to 1272 degrees. And I had to subtract 360 3 times to get there, but it was easy to do. I just did it on my calculator. Now, what if I'm asked to find an angle coterminal to a negative angle? Let's see. Let me erase this, and I'll erase this. And let's find an angle coterminal to negative 751 degrees. Well, in that case, I'm starting with an angle back here somewhere, right? I'm going in the clockwise direction. To get to this angle, I have to have gone in the clockwise direction. So if I want an angle that's between 0 and 360 that's coterminal to this, I'm going to have to back up. I'm going to have to add 360. So I'm going to take negative 751 degrees, and I'm going to add 360 degrees. And again, just using my calculator, when I do that, I get negative 391. That's still less than 0, so I'm going to add 360 again. And you can probably see I'm still not quite going to get there. This gives me negative 31 degrees. So I'm going to have to add 360 one more time, and that gives me 329 degrees, this time positive. So this angle, 329, is coterminal to negative 751 degrees, and it's positive, right? These are all actually coterminal to negative 751. But the one I want, usually, is the one between 0 and 360. So that's why I stopped when I did. Now that's a pretty simple process, but what if it's in radians? The last thing we need to look at in this section, or in this subsection in this topic, is what if the angle we're given is in radians? Let's see, what if I ask you for an angle coterminal to 19 pi over 3 between 0 and, it's going to be 0, not 0 degrees, but 0 radians, and so I don't need a label at all. But I'm going to have to convert this from 360 degrees to 2 pi radians. So again, 2 pi radians, but without the label, because radians are unitless, right? By unitless, I mean we don't need a degree symbol. We don't say 497 centimeters. Centimeters is the unit there. We don't need units with radians, so radians are unitless. Well, 19 pi over 3, let me try that again. 19 pi over 3 is coterminal to some other angle in radians. Well, if when I'm working in degrees, I subtract 360 degrees, when I'm working in radians, I need to subtract 2 pi. Oops. So I'm going to subtract 2 pi from this. So this is just a case of doing some arithmetic. You could do this on a calculator, but you have to be careful with pi because you're going to get an estimate. I want this in terms of exact values. So I'm going to rewrite this problem in terms of, I'll just write it first of all as 2 pi over 1, and then I'm going to multiply it by 3 over 3. And that gives me 19 pi over 3 minus 6 pi over 3, and that is 13 pi over 3. So 19 pi over 3 is coterminal, is equivalent to 13 pi over 3. But is 13 pi over 3 less than 2 pi? Well, 3 goes into 13 at least 4 times, because 3 goes into 12 4 times. So this is more than, this number here is greater than, what did I just say, 4 pi, right? And we need it to be less than 2 pi, so we're not done yet. Let's take this and do the same thing again. 13 pi over 3 minus 2 pi is 13 pi over 3 minus 2 pi over 1. We'll multiply that by 3 over 3. I'm doing that to get a common denominator. That's 13 pi over 3 minus 6 pi over 3. And of course, that's the same as I got here. So I'm basically going to subtract 6 pi over 3 each time, right? 13 pi over 3 minus 6 pi over 3 is how many pi's over 3? 7. 7 pi over 3. 3 goes into 7 a little more than 2 times, right? 3 goes into 6 twice. So 3 goes into 7 more than twice. So this is still bigger than 2 pi. So I need to subtract 2 pi again, or 6 pi over 3 again. That gives me 7 pi's over 3 minus 6 pi's over 3 is 1 pi over 3, and that is less than 2 pi. So that's my answer. This is equivalent to, or coterminal with, 19 pi over 3, and it's between 0 and 2 pi. It's between 0 and 360 degrees, right? Or in radians this time, but the process is exactly the same. All right, that's it for this video. In the next video, we're going to be looking at determining the length of an arc.